Thanks so much for having us. It's a real pleasure to be here and looking forward to having a really interesting and hopefully insightful conversation about some really cool developments in the accessible tech space. So we're really fortunate to be joined by three fantastic speakers, actually all over the world for today. So we've got some in Japan, in the US, and in the UK. So first, let's introduce Chieko Asakawa. Chieko is an IBM Fellow in Accessibility and also a distinguished professor at the Carnegie Mellon University. Hi, Chieko. Thanks very much for joining.
Hi.
We've then got Hideki Yoshimoto, who's a designer and engineer and the founder of Tangent, a lighting brand based in the UK and London. Welcome to you, Hideki. Thanks for coming as well.
Hi, man. Thank you.
And last but not least, we have Kris Kitani, who's an associate professor at the Carnegie Mellon University and works in the computer vision and machine learning spaces as well.
Yep. Hi.
Thanks for coming. So if I could just ask each of you in the order I just introduced you, just to kind of give a little bit more context about what you work on and your introduction as you'd like to be presented today. Chieko, starting with you.
So Matt, do you want me to just introduce myself first? Or?
Yes, please. Yeah, okay, that'd be great.
So I'm Chieko Asakawa, and I've been working for IBM Research for like 30 years, and I have been focusing on accessibility research, and I am myself visually impaired. Today, I will talk about the AI for accessibility.
Thanks, Chieko. Now, Hideki, just give us a little bit about yourself.
Yes. Hi, so my name is Hideki Yoshimoto. I am a designer running my own studio in London, although I am streaming this from Japan, where I'm from now. I'm working on a project which Chieko is leading, and then we will talk about that. Nice to be here. Thank you.
Awesome. And then, Kris, if you could say a few words about yourself as well.
Sure, yeah. So I've been working with Chieko at CMU for about 6 years now. As Matt was saying earlier, I've been working in computer vision and machine learning, and Chieko and I have been talking a lot about how the technologies that we've been developing can be used to help blind people. So we're excited to talk about it today.
Awesome. Thanks a lot, Kris. And then I guess I should introduce myself. My name is Matt. As Ellie mentioned, I'm the CEO and founder of Sociability, a mobile platform to help disabled people find accessible venues. And I've got a background in law and have recently finished a master's looking at the ethics of automated decision-making systems. So really interested in some of the stuff that we're talking today about how technology really impacts people in the real world. But without further ado, let's jump into it. So we're going to hear three presentations, one each from Chieko, then Kris, and then Hideki. And then we'll have a panel discussion where we speak to each of the panelists about some of the intersections between their work before then moving into the Q&A session from 4 o'clock. So without further ado, Chieko, if you want to take over, we'd love to hear from you.
Okay, thank you, Matt. So first, thank you very much for giving us this great opportunity to discuss AI-based mobility for the visually impaired today with you. First, let me briefly introduce myself. When I was born, I was sighted. By the time I was in junior high, I grew to love sports. People around me thought I could become an Olympic athlete in the future, but nobody had any idea that I might become an IBM Fellow. When I was 11 years old, I hit my left eye on the side of a swimming pool. And by the time I was age of 14, I was blind. After I became blind, I found that there are two difficulties for the blind to live. The first difficulty was to access the information. In those days, there were no personal computers, no internet, no smartphones. I couldn't read textbooks, newspapers, magazines, any book by myself. Another difficulty was mobility. I couldn't go to school by myself. I couldn't go out for shopping by myself. I couldn't go anywhere by myself. I really wanted to be freed from relying on someone. I really wanted to be independent. That became my strong need, pushed my back to ignite innovation. After many twists and turns, I joined IBM Research and started working for accessibility. IBM has been a big part of the history of accessibility technology and promotion. Back in 1914, IBM hired its first employee with a disability. That was remarkably early, long before society began paying attention to such issues. In 60s, IBM developed a talking typewriter shown in the slide. I'm very sure most of you in today's audience would have maybe never seen even the typewriter. But anyway, IBM has developed it in 60s. Then Talking 30 to 70 terminal was developed in 1984. There is a picture of me using the terminal. Actually, it became available when I joined IBM. In the 90s, people around me started talking about the internet and web browsing. I remember the first time I went on the web. I was astonished. I could access newspapers at any time and every day. This became my aha moment. This led me to develop the IBM homepage reader in 1997, first in Japanese and later translated into 11 languages. After homepage reader became available, I received many comments from users. One that I strongly remember said, "The internet is a window to the world." It showed it is really important for us to access the information to participate in society. Now, my focus is real world. Currently, while exploring a city, I cannot recognize shops around me, products in the shop, if there is a long line, if my friend is approaching me. I can't perceive all these kinds of visual information by myself. And that is my research challenge today. So this slide shows my exact goal. It is very, very old Japanese animated character. I liked it when I was a child and could watch it. The little bird on his shoulder is a robot, and it helps the boy by whispering to him about everything around him, from the weather to approaching enemy. It was a kind of science fiction. In the era of AI and IoT, the bird could be no more fiction, but it could be possible by technology. It could notify me traffic lights, crossing, bicycle on the street, stairs, escalators, elevators, any information for me to walk by myself. Even now, such technology may tell me what's going on the screen. But this is going to be really new challenge in this era. So as a first step toward realizing the vision, we developed a navigation app for iPhone for the visually impaired, which assists them to move around locations in the real world, specifically complex indoor locations such as schools, shopping malls, stations, airports, hotels, and so on. So there is a picture of this system that blind people are really using it in Pittsburgh. So please, could you please play the video one?
Approaching. Go up to the 6th floor by elevator on your right. Turn around. You might be going backward. Proceed 25 meters and turn right.
It's an awesome experience. It makes me feel free to go where I need to go. This morning, I got out of the Uber car, turned on NavCog, and from the outside of the hotel, walked inside into my room without asking anybody for help. It was just great.
Champions Club is on your right.
NavCog. I had my phone in one hand, my cane in the other hand. I never walked with such confidence in my life.
And my favorite part about it is the ability and confidence that I have to walk somewhere. And when someone stops me and says, "Do you need some help?" I can say, "Nope, I got it. Thank you." And I'm on my way. So
we can cut to maybe Kris just to talk a little bit perhaps around some of the kind of technology that might be involved in some of the NavCog technology that we just saw, because I think that sort of touches on a fair bit of the stuff that you're working on specifically.
Sure. So I could talk a little bit about just the video that we saw. So that's NavCog is something that we developed with Chieko, Shimizu Construction, CMU. And, it really is helping people to navigate indoors. That technology is based off of Bluetooth beacon sensing and using some of the odometry or the IMU on the phone. And it gives turn-by-turn instructions. It has, speech search. It gives you information about points of interest. And, yeah.
And so is it that the environments that people are in have to be set up beforehand? So in the sense of like there are kind of certain environments in which that technology will work because of the beacons or things like that, or it's sort of more broadly applicable?
I think some of the underlying technologies make it broadly applicable because it's algorithms for localization. But for this particular case, we really needed the Bluetooth beacons for accurate localization. So things like finding buttons, like elevator buttons, or the difference between two doors really requires like accuracy down to maybe less than a meter. And so that's kind of the direction that we're pushing in now is how accurate can we get the localization so that we don't mistakenly lead somebody down the wrong hallway or into the wrong door.
Yeah. A really important challenge. Thanks, Kris. Well, Chieko's back online now, so we'll just cut back to her presentation just to continue on from where we left off after the video.
Yeah. So can you hear me?
Yes,
No?
I think we can hear you.
Okay.
Yep, we can hear you. We can hear you loud and clear. Thanks, Chieko.
Sorry. Okay, thank you. So maybe this situation is a really newly appeared problem, for me, because I'm using a screen reader together with the online meeting. But anyway, let me continue. So, okay, I'm really, so I hope you got the point of NavCog application. And I'm really excited about the NavCog deployment, but we still need technologies to recognize things surrounding us. Object recognition is one of such technologies. It is rapidly advancing, but it sometimes makes mistakes. Really, this is a very interesting and simple example. Sometimes it says Diet Coke for beer. It happens, but it is very critical because we should not open the beer during the daytime. Even if object recognition engines become more, intelligent, one thing they cannot recognize is personal item, not generic item. The left side is a T-shirt I got from Grace Hopper celebration in 2017, and the right side is a mug from a university in Spain. But I cannot recognize what it is just by touch. So we developed a personal object recognition system. POR is a smartphone app that we developed specifically for the visually impaired. It is based on deep learning system, and blind people themselves can train the engine. And there is a video, so we are going to play the video too. I hope this time I'm not going to be lost. Please play the video too.
Create a new object. Double tap.
A cup of a CogX research lab in 2015.
Ready to take photos. A bit left. A bit left. A bit left. Move. A bit right. Move.
IBM research t-shirts from GHC 2017.
Ready to take photos. A bit left. Move. A bit left. Move. Further. Move on to the next side and swipe right. Ready to take photos. A bit left. A bit left. Sending images. A cup of Egokuna's research lab in 2015. Right. Ready to take photos. Sending images. IBM research t-shirt from GHC 2017.
今見えないのか。Okay. So, we train the system by ourselves, and then after the training, our system can recognize what it is. And by the way, this technology has been published Kai this year. So if you are interested, please refer our paper. So another exciting challenge is scene captioning. I like traveling and sightseeing. Of course, I can feel the atmosphere, environmental sounds, voices of people, and so on. But if I can recognize what's exactly there, it will change my everyday life. I'm going to show some examples. I have several pictures from Lisbon, and there are 3 pictures, and each has captions. And can you play the first audio?
A train on a track near a building.
So when I hear it, I can imagine what it is. And could you play the second one?
A beautiful view of an old building in the background.
This is just a scene captioning, but if we could integrate, GPS information, I'm pretty sure the system should be able to say what this building is exactly. And the third one, please.
A white plate topped with lots of cheese.
Yeah, this is a very interesting example. So this scene captioning system was not trained to understand the, egg turtle, but this is Lisbon, Portugal. So this is very important, and I love egg turtle. But many of you should be able to, guess if AI engine is trained, it should be very easy to say it egg turtle instead of cheese. So there are great potential to use such system to see the world or to explain what's around blind people. So I'm really excited to use this technology practically. Okay, and this is really cutting edge AI technology targeting blind people. The unique, initially, of course, it can use for many other purposes, but initially they have targeted to help blind people. So the unique needs of the people with disability has been, helping larger AI technology. So the next is AI suitcase. So AI suitcase is a project I'm working on now. By integrating perception, planning, and control, suitcase could be a new travel companion for us. Why? Please take a look at the video. Video 3, please.
Take me to the United Kiosk.
Okay, United Kiosk. There is one person in line in front of you.
Hi. How are you? Good. How are you? Good. Okay, going to gate A6.
Okay, going to gate A6. Train is here. We are entering the door on the left. Escalator in 5 meters. Escalator approaching. Carry me.
Excuse me.
Flight has been delayed by 3 hours.
Oh, well, let's get a coffee then.
Okay, going to food court. I see Dragon and Ashed. They are eating hamburgers.
Hi, Chieko.
Hi, guys. Oh, good to see you here. But, Ashed, why are you eating a hamburger? Aren't you a vegan?
Oh, it's a veggie burger.
Sorry, I bumped into something. I didn't see it. Let me add it to my data set.
Okay. Yeah, so this video really shows how AI can help the blind navigate in the world. And this slide shows our past prototypes, and it has been pretty difficult to develop this kind of technology in a suitcase-shaped robot because of the size of the motor, batteries, computers, and it needs to be lighter, to carry around. So we have been challenging and tackling and solving a lot of problems, and we are planning to do the real-world experiments in this year. And for this project, I have been collaborating with Hideki and Kris for today's, who are attending today's panel. Okay, so also this technology the paper for this technology has been published in the last year's SCM conference related for accessibility. And when we have conducted the user study, we got a great, comments from users. And one of the users really liked it, and she had a, guide dog with her, but she decided to call her dog Cabot. Cabot is our temporary name for this robot. And she said she want to call her dog Cabot. It's a really interesting joke. So we are hoping to show you the next generation very soon. So accessibility needs ignited various innovations in the history of technologies. Telephone was invented while developing a communication tool for hearing impaired in 1800s. You can easily imagine how OCR and voice recognition work was motivated by the needs of people with disabilities. The next big thing is, of course, AI. Accessibility could be a flagship use case of cutting-edge AI technologies, and I strongly believe it will lead us to the next generation breakthrough invention. And this is going to be the last page. So now we are facing the new era. So we got the new, research challenge. How technology can help the blind, people with visually impaired, live in the new normal era. I don't have the answer today, but I have already thought about, a lot of, technical challenges, and I'm pretty sure we can, solve some of, today's problems in the suitcase project. And, we see a lot of, survey results, how people with disability, live in this difficult era. So from now on, we have to think about new challenges and solve those problems using technologies. Thank you very much.
Thanks a lot, Chieko, for that really impressive and interesting presentation. It was great to see some of the different technologies and how they've evolved during your time working in the field. We'll now just cut to Hideki to hear a little bit more about his work, particularly on the design side of things. Sorry, I meant to Kris, particularly his work around the computer vision and the slightly more technical side of things involved in some of those examples that we saw and some other ones that he'll discuss now. Thanks, Kris.
Yep. Yeah, so we've kind of put these slides at the end to give, I guess, the Q&A session a little bit more context. So, like I said, I've been working with Chieko on different technologies. And this is just kind of an overview of some of the projects that Chieko and I have been working on. So the first one is this deep radio visual localization. So you actually saw a version of this running for NavCog. Right? This is what was being used to do the localization. But we've been looking a lot into how to use Bluetooth beacons that are embedded in the environment. And then also, in this case, the camera on the smartphone. It could also be a camera on the AI suitcase. So we've been developing various deep learning algorithms that really advance the state of the art in terms of localization. And as I mentioned earlier, we really want to get really good accuracy because we are giving turn-by-turn instructions, and really each meter or each centimeter really matters. We've been working on other things like pedestrian detection using a camera. One of the things I remember, early on when we were running tests for NavCog was, people would just be standing there and they don't realize that Chieko is kind of walking by, and I always felt that it felt kind of dangerous because I felt like she was going to crash into them. So we've been working on pedestrian detection for that. We've been also looking into the top right here, forecasting time to collision. So if we can detect people, we can see how fast they're walking. We can also compute how fast the AI suitcase in this case is walking. We can predict when there might be a possible collision or getting too close to something. So we have projects on that. That was published at a robotics conference last year. And this last project here, the sonic collision avoidance, this is something that we've been thinking about internally is, instead of only expecting the blind person to navigate around everything, would it be possible for the system to somehow interact with the environment or with the people nearby, letting them know that, that somebody's coming through. And this particular system is using audio. There's probably different ways to do it, but this is something that we've been thinking about a lot, is how do we interact with people? And this pulls in a lot of ideas and research from human-robot interaction, computer vision. So that's kind of another area that we've been looking into. Yeah, so that's it for me. Thanks.
Those technologies a little bit more. We can discuss them in the Q&A session, the panel discussion subsequently. And now just for the final presentation from Hideki, just to go into a little bit more detail around his work on the design side of things and how that factors into some of these technologies that Kris and Chieko have been working on. Thanks, Hideki.
Yeah, thanks, Matt. So I am working as a designer, running my studio called Tangent in London. I wanted to introduce a few examples of my practice here. It may, this slide may not look relevant to the Chieko and Kris' work, but I'll come back to that point. You can guess that, on the right end with the suitcase image. But the first one on the left, this was a commission from the Dubai Design Festival in 2016, where my team created a beautiful video animation to be screened on the whole facade of the massive Burj Khalifa, the famous, obviously tallest building in the world in Dubai. That was really, really spectacular. And the second one in the middle, my team designed an entire exhibition booth for Hermes for their fair, their exhibition and the fair of the really luxurious watches in Geneva called SIHH last year. And we designed the whole space, designed the showcases, windows, and in the middle of the space, in pictured here, we designed and made this big sculpture of the planet Earth, which we created out of the recycled solar cells to deliver a narrative about their brand, their products, and then their message about sustainability here. And the last one on the right, this is the suitcase, which I designed and developed with a British luxurious luggage brand called Globetrotter. And this is like a brand new carbon fiber suitcase, which is super cool. We developed from the material, special material, which is patented. And because of this, recent experience of designing a suitcase, when I met Chieko last year, I was really impressed by her project, and then I was really interested in her AI suitcase project. So immediately I spoke to her and I said, I think I can help you with my design for the AI suitcase project. So that's it from me for now. Thank you.
Awesome. Thanks, Hideki. Really, really cool to see some of your projects there. And also, of course, the last one, which is really relevant to the AI suitcase. And we can dig into that a little bit more. And also the importance, I think, of designing products well for people to use them in the real world in just a little bit in the panel discussion. So we have about 13 minutes left for this kind of first part of the session. So we'll bring back all the panelists now. And I've just got a few questions that I think sort of speak to a little bit of the intersection between each of their work. And so we'll have a panel discussion, and then we'll move into the Q&A after that, where we can get a little bit deeper into some of the details. So the first question is a bit more to Kris and Chieko, but feel free to chime in as well, Hideki. It's a little bit around, I guess, the mainstreaming of accessibility as a use case for some of the technical research and development that you guys are working so closely on. So Chieko, you spoke a lot about how, particularly for AI, accessibility could become a real flagship use case. But I was wondering if you could speak to, I guess, a little bit of the evolution over the past few years and few decades in your time in the field, as to how accessibility has become a much more mainstream use case for the technical research, and I guess what that means, or some of the reasons why you think that's been happening, and what you think that means sort of moving forward in terms of how the real world impact of these technologies will be.
Also, Matt.
Yeah.
Do you mean you want to know the examples of the accessibility technology that became available for the mainstream?
Yeah, I mean, if you can speak to that, I guess as part of it, I'm just interested in hearing your thoughts on why you think that accessibility might be becoming a more popular, use case for some of these technologies, or a more common or mainstream sort of focus for research. Yeah,
of course. So as for the soft like information accessibility, I have already briefly talked about in the a page, accessibility ignites innovation. So like OCR or voice recognition work, they started helping people with disability first, but now it has been used for the mainstream. But for the real world accessibility, Kris talked about the localization. So currently people without disability can use various navigation system with maybe like a GPS, with a GPS. But for the blind people, GPS accuracy is not enough, because sometimes it has 10 meter or 20 meters gap. So when it says turn right, we are still not there. So we really need the accurate localization for accessibility purpose. But once it became available, of course, it's going to be useful for everybody. We would be able to find out where you are exactly. So it should be useful for the, emergency, to find out where you are. So there are a lot of other use case scenarios if, we could reach the accurate localization, which is really challenging technically. But we really need it for accessibility purpose. That is maybe one example. And maybe Kris might have more.
Yeah, I mean, I think speaking maybe from the, let's see, so two aspects. So the state estimation, so that's localizing somebody. That technology has been around for a while. It is pretty mature. And I mean, I think it's because of that maturity that we've been able to introduce it into a system like NavCog and this indoor navigation. Computer vision, specifically for object recognition, I really think that it's advanced a lot in the last 10 years. A lot of it has to do with advances in deep neural networks. And so Chieko showed that example of the personal object recognizer. And we also saw examples of like human pose estimation in some of the videos. Those technologies really didn't come together until very recently. And I think because of those advances, we've been able to push them more into accessibility applications because they're robust enough, they're reliable enough, and they're fast enough to be helpful. And it wasn't the case like maybe 10 years ago.
Yeah, really interesting. And I guess to push on that point a little bit further, Kris, what are some of the things that are kind of still stopping what are the kind of the biggest barriers at the moment in some of those fields that stop it from getting to, that kind of level of specificity or accuracy that Chieko is talking about that is really needed, when we're talking about real people in the street, walking on a road next to a car or things like that? What are the kind of areas that you guys are working on to really try and push those boundaries?
Yeah, so that's a good question. So what are some of the boundaries in terms of technology? I mean, I think one kind of big challenge is the fact that a lot of the modern system need a lot of data to train, and it's not so easy to get. You saw the example where Chieko was like taking pictures with the phone, and the phone was telling her, what view to take the image from, and that process right now, it still requires several images that you have to take, and I think it's the same thing for other types of like data-driven methods. It's just, I think that's kind of a big wall right now, is the requiring a lot of labeled data.
So Matt, can I add something?
Yeah, Chieko, that'd be great.
Yeah, so, and technically, of course, there are a lot of challenges to make things more accurate, but also we need societal understanding. So Kris talked about the data. Currently, it has been really challenging to collect the data. It is, almost impossible to get approval or, consent from everybody in the world when we get the data. But we need that data. So how we can collect the data we need, that is really challenging. So one of the good examples is understanding people or whatever object. So how we can, even, we tried to recognize maybe, let's say like a queue, a long line. We need the data to recognize the queue, but we have to collect the data from the real world. We don't need to recognize who you are. However, we need to collect the data of a lot of lines or queues at the airport or at a cafe or whatever. But, people will not like it. Maybe they will think, we might be capturing their faces or things like that. So we really need a societal understanding to collect the data.
Mm-hmm. Yeah, and I think two really good points there around how, one, that this technology, it needs to be embedded in the real world, and people, use this information because they want to achieve a goal or a task, or it's, to help them to actually do something. And that also means that we need to kind of educate other people around, in that world as to what technology is doing for them and how they can kind of help facilitate that. And I think that sort of as a nice segue into Hideki, your kind of role in this, where it's really focused on, design and actually making sure that people are able to, both use the technology in a really user-friendly interface, but also that, they want to use the technology, and it's, it looks good and it's trendy, and it's something that they could be proud to kind of have as part of their daily experience. So I was wondering if you could speak a little bit to that around the kind of the importance of, of design and of user-led, I guess, interaction for building these technologies.
Yeah, exactly. So there are people who have difficulties in doing something, and obviously various technologies can help them to do that. But I don't think it's enough, because they should be able to do that comfortably and with confidence. And in this particular project, the suitcase project, for example, when I joined this project, and then I saw the prototype, it was like a bulky robot, which might look like a suitcase, but might not. And people would say, this is a robot, not a suitcase. So my role, for example, in this project was redesigning it and then making it a real beautiful suitcase. So I invited a Globetrotter, the suitcase brand, as a production partner, and then we redesigned it completely using the model I designed for the Globetrotter as a basic platform. So now the story has changed completely because it's no longer a navigation robot which helps. Well, it is a navigation robot, but people would say that this is a super cool suitcase, really beautiful, sophisticated suitcase. And by the way, this has an AI function and robotics functions and helping its special user. So it's completely different, from a bulky, weird this thing, blind people, for example, at the airport. They are using this cool suitcase comfortably and then enjoyably, various parts of the city. So I think that's the what designers can do for that kind of project.
Yeah, that's fantastic. And I think there's a really important part there around, both encouraging kind of everybody else in society really view disability and I guess the accessibility technology associated with that in a different way as something that is, it's exciting and it's helpful and it's not something to sort of be kind of afraid of or confused by or, think it is a little bit embarrassing. But then separately also encouraging the users of that to really embrace that and to be, proud and able to go out to show it off. And I think there is, a lot of importance in how we kind of perceive disability and therefore also the kind of technology that we use to help it. And so it's really cool to see some of the exciting work you guys are all doing in that space. Well, I think we're coming a little bit to time now, but it probably gives us a good segue to transition into the Q&A discussion, some interesting points there, which people can submit questions to the Slido on to ask further about, or if they have different things, they can also submit. So I think we're going to transition now into that Q&A session. But just before we do that, we've got a brief 4-minute video from you, Hideki, just showcasing some of your design work. So if you just maybe want to give us a very quick introduction to what the video will be, and then I think we'll play it.
Yes, this one is like a showreel of my practice, really artistic, from artistic ones to scientific or engineering ones, just to show to introduce my practice.
Great.
Thank you.
The place I was born and raised up was very close to the sea and mountains. Inspiration from nature is very important in my creation. I often use light in my work, and I like giving it emotion. The light will look as if you see it in nature, but it's not real nature. It's kind of between reality and fantasy. That's where the poetics of my work exists. Things like electronics and computer programs are useful. Those are the tools which I use to realize what I want to see. Technology is ever-changing, updating what we can create. The important thing is, however, for what we use those technologies and how we do that. I don't want to impose technology for its own sake. I want to use it if it helps me to deliver a beautiful thing and delightful time to people's lives. Since I set up my company, we have done some amazing projects. I collaborated with a graphic designer, Yusuke Murakami, to create a beautiful animation screen on the whole facade of the Burj Khalifa in Dubai. My team designed an exhibition for MS. The central piece was a large sculpture of the planet Earth, which we created out of solar cells. We bought a very old stock of photovoltaic cells and cut them in triangles using water jet cutter. These cells were given the second life to tell a narrative of sustainability and the poetic story of the brand's concept. Technology is great, making our life easier, more exciting, but it's not enough. We cannot live without seeing or hearing beautiful things. We just realized it because of the pandemic. My interest is in how a humble use of technology can make that.
Want access to more CogX videos? Subscribe now for free at cogx.co.